This is a SUN-2000G2 model grid tie inverter with limiting. The display board has a battery on it. This is the DC input. These are the DC fuses, 230 amp fuses in parallel. These are the filter capacitors. There's two groups here of 5 at 1000 microfarads at 100 volts each. This is a DC control board. Underneath the DC control board is a power supply. It has two separate outputs. Well, actually three. One is 12 volts that runs along this ribbon cable over here to the AC control circuitry, which is isolated from the DC. This also supplies 3.3 volts to this board and 12 volts with a common connection on them. This is a ribbon cable here, it goes up to an RS-232 input. These are the DC to DC transformers, and the FETs that drive them are all along here. There's 8 on each side, 2 per transformer. On this side we have the IGBTs, and then these are SCRs. These two chokes are part of the line filtering, I guess. Each one of them is connected to the line output, and the SCRs and the FETs. This is a current transformer for the output of the AC. This is an AC, I'm not sure what it's for, a sampling transformer. It's just a one-to-one transformer that's connected to the AC output. And they have some additional filtering here. There's 2 inductors, some capacitors. They're all in the AC line. There's a common mode choke here. AC 15 amp fuse. And I don't know if I mentioned or not, these are the rectifiers for the high voltage. So the secondary on these transformers are all series. 2 transformers are in series, and then the 2 series are in parallel, and they go to these bridge rectifiers. Same on this side, and then both the positives are connected together and the negatives are connected together. Starting from the DC side, you have your 2 input terminals. Get the black one and the red one. The red one goes through red wires inside to a 230 amp fuses, and then it gets combined together and it's referred to as PV plus after that. The negative terminal, which is black, goes through 2 green wires, goes to the circuit board, goes through 2 4 milliohm resistors in parallel, and that becomes the PV minus, and I assume there's some sort of current sensing going on there that goes to that main DC circuit board. After that, it goes through 6 of these transformers, inverter transformers, and there's for some reason one of them is unique. This one that has Q17 and Q16 in it, it has on the source, it has these 0.004 ohm resistors in each one of them, and they're tied through these 1K resistors to a point on the control board. But each one has they're all identical except for that. And they have a center tap transformer with the positive going to it and the negative going down here. And they all have a bypass capacitor that's mounted right on the transformer that goes from the plus to the minus, and they're little brown polyurethane capacitors. I don't have the value for them. I didn't think it was important at the time, but they seem to all have this same number circuit with a resistor and a capacitor across the coil. And here's a chart showing the designations that are given to each one of the resistors and the transistors in that, or the FETs in that circuit. After it goes through that, there's a transformer. Apparently they're in pairs, so you have two of them in series and then two of them in parallel, and that would be for one side of the board, and it has its own bridge rectifier. And then the other side of the board, same thing, with a separate bridge rectifier, but they're tied together and they become, I don't believe they have any designation on the board, but I just call them V sub 2 plus and V sub 2 minus, and that goes off to the AC section. These FETs are all driven by these drivers here that they're also marked in this chart here, the driver numbers. But it's kind of an odd thing. They have one of them will have a 30 ohm resistor in series with it, and then it connects to these two, or the 4.7 on the FETs themselves, but then some of them have two 15 ohm resistors, like right here and right here. So I don't know the reason for that, but they both go off to this the DC control board, and they're labeled PWM-L and PWM-H, and this is the control board. If you look at it from the top, there's a row of 12 pins and another row of 12 pins in 90 degrees to each other, and then in the corner there's a row of 4 pins. The 4 pins have a they run off to the control board through this connector, the ribbon cable, or the main board I should say, and that goes off to the AC converter control board. This is the power supply for the two control boards. There's a black and a white wire that runs off from the AC side over to where the DC control board is, and it has a connector, and it comes in here, and it goes through a bridge rectifier, filter capacitors, and then it has a transformer here with a control IC that does the switching on it, and it has feedback on just one of the 3 power supply or voltages that comes out of it, and that happens to be the 3.3, and that goes to the DC control board, but it also generates a 12 volt plus 12 volt supply that goes to that DC control board with the same ground reference, and that ground reference is tied to the negative terminal of the DC input. There's a second secondary winding that's completely isolated from that one, and that generates 12 volts also, and that runs off through that ribbon cable to the AC control on the main board. My particular inverter has terminals. It has line, I believe it's line 1, line 2, and a ground, but when they go inside they're labeled AC1 and AC2, and it goes through, it comes in, and there's a transorb and then a capacitor, and then there's a 15 amp fuse, and then 2 more capacitors, and then it goes, there's a little black rectangle unit that's on the board that's actually an isolation transformer. I'm not sure what it's used for, but I imagine it goes off to the AC control section of the board. Then it goes through this coil here, and then 2 more coils. These are separate coils, so this is just one coil, and this is another capacitor, and then there's a current transformer, and then a transorb, and then they go off to the AC conversion. And it's kind of, they're both sides are exactly the same. They have there's just one IC that drives, these are IGBTs, that drives, there's an IGBT on 2, and then there's another IGBT on line 1 here, and but the circuits are identical. They take that the high voltage that's generated by the DC supply, it goes through a big coil. It's just a toroid that's mounted vertically on the circuit board. It goes through an SCR, and then through the IGBT, and then it goes through 2.03 ohm resistors in parallel, and then to the negative side of the high voltage. And so this IGBT and the one up here is driven by this same IC. It has 2 drivers built into it. The SCRs have their own separate drivers. They're white ICs that are on the board there, and so there's 2 of them. And then there's these 3 capacitors that are tied across all that stuff. I drew them in. This is the current sensor jack that's on the back. It actually has 2 designations, 1 and 2, and they come in, and it goes to the DC control board. And I looked on the board. There's actually a 50 ohm load resistor that goes across that current transformer on the board, and then one side apparently is just tied to a 1.7 volt DC reference. The other side, I assume, is going to the conversion circuitry that's on the DC control board. On one of the heat sinks there's an actual, it looks like a thermistor, but it's actually a switch, and that goes to the DC control board as well. This is a parts layout I drew for the unit, the DC side. So this would have the DC terminals on it, and this is a bottom view. These are the FET numbers: 16, 17, 20, 21, 26, 25, 29, 30, and then on this side 22, 23, 18, 19, 31, 32, 28, 27. And these are the transformer numbers here. Got 11, 9, 7, 5, 8, 6, 12, and 10. And these are all paired with these MOSFETs. Then underneath the board there are 4 high voltage rectifier diodes on each side, and this set is all tied to these diodes, and this set is tied to these diodes. And then there's your IGBTs, and then your SCRs that's on the AC side. The power supply, the DC to DC power supply, or AC to DC power supply that is on that powers the control boards. This is I couldn't actually find the data sheet for the MOSFET, but this one looks like it's close. This is the part number for the driver for the MOSFETs, part number for the high voltage diodes. This is for the SCR. the SCR driver, the IGBTs, and that's the IGBT driver. This is alternative to the IGBTs. It's a STGF20H65DFB2, and what's nice about it is it's got a plastic case on it, so it doesn't need an insulator. This is an alternative to the current transformer. It's an SCT-013. You can buy this off of Amazon, and I've checked it. It's got the same characteristics as the one that comes with the unit. Schematic for the AC side, or not the complete schematic, but the part that I chose to draw. There's the one for the DC side.